An introduction on data analytics. Uh, so before we get into know what you mean by data analytics, we will see some terminologies related to that. So what do you mean by a variable, right? Uh, okay, you understand that variable is nothing but a characteristics of an object, right? It may be anything. See, for example, you consider I have to maintain a database, in the sense you want to maintain your class details, right? What are all the information you will collect? You will have student name, register number, right? His mail id, phone number, all the this are the four preliminary things you will collect, right? This four preliminary things, the name you give for the, for example, student name, student register number, contact number, mail id, all this could be a variable, or even you call them as dimension, right? Or you call them as the characteristics that represent a student, right? So a variable is nothing but the characteristics of an entity that is going to be studied. If I want to maintain, information about student, so what are all the variables or what are all the characteristics I want to know? For example, you take our IoT class, what are all the information I collected from you? Apart from what I mentioned, I collected you your year of study, right? I collected year of study and the branch, right? So this are all, you call it as variables. Okay, what do you mean by measurement? The standard process to assign number to that particular attributes, you call it as measurements. For example, uh, now let me include one more variable, say your mark, as your quiz mark. The way how I measure this quiz mark, I posted you a Google form. Based on the answers you given for the questions, the mark is being assigned, right? This is the kind of measurement I used to assign value. And for register number, it was already given to you, right, as a unique number. This is for your understanding, right? So the measurement is nothing but the way you assign values to those variables. So what is this data? The value which you assign for that variable is your data. For example, let me consider myself as a student, and I have given the value as Sumati. Then my height, register number, all the values I provide are nothing but the data, right? Okay, so with this introduction, so now you should be able to differentiate what you mean by variable, measurement, and data. And only if you have data, you can do analysis or whatever analytics. Okay, what is this analysis and what is difference between this analytics, or both they equal? You people were quite familiar about when we have a class committee meeting, we will have our unit test analysis, result analysis, right? What you do there, you find how many of the students have passed in each and every subject, what was the average, minimum and maximum mark in each and every subject, right? If it is in subject wise, if you take a student, in how many subjects he has passed, in how many subjects he was not able to get through, all this kind of analysis you do with the data you get it from the unit test for your, yes, that is what your analysis. What is analytics? Analytics is nothing but with the data you have, you make some predictions about the future. For example, based on the data I have with me on unit test 1, 2 and 3, if I'm able to design a model that gives me prediction of whether the student will be able to get through in the end semester examination, that is analytics. Analysis is nothing but just making an analysis about past. Analytics is nothing but from the information I was able to predict future. Right? That is the difference between analysis and analytics. Okay. Mm. So why this analytics is important? This analytic is important to determine credit risk. This is like predictions for develop. So I have pointed some few applications. uncovering your cyber threats. In gender, you have it as to make your predictions. To make predictions, classifications, you go for your analytics. Okay, this is what we have discussed previously. Analysis is when to past. It will give you the answer for how, explain why, and analytics give you information about future. It helps you to explore future events, right? And in analytics, you can have either qualitative or quantitative analytics. What is qualitative analytics? It is like you make intuition. That is, let me say, you say this person is so good, right? You may have a comment like, see, this person is so good. If I post you a question, how you measure that goodness, you cannot say it in a word. But if you say this person is so height, and if I post you a question, how you mention, how you are able to say that, you will say the person is 161 centimeter, right? You are able to give quantitative measurement, right? That is what the difference between qualitative and quantitative. If you just give intuition of how this was happened, right, with some basic assumption, that is qualitative. Quantitative means you use formulas and algorithms to tell, or you make the predictions. And from we will be focusing on quantitative, right? Okay. So what are all the types of analytics I can do? I can do descriptive analytics. That is nothing but it just tells me what happened. And why did it happen is your diagnostic analysis. What will happen is your prediction, and how can we make it happen, right? How we can make it happen is your prescriptive analysis. And normally we will be focusing much on predictive analytics, and the most higher end is your prescriptive analytics, and we will not have a touch on that. Okay. Shall I proceed further, or you want any point to be repeated? Okay, fine. Okay, that's good. Okay, what do you mean by types of variables? As you know, what is variable now? Why I should know the type of variable? Only if I know the types of variable, I can perform some operations on that, right? So, what are all the types of variables I have? Categorical variable and numerical variable at broad sense. Categorical variable means it is like you don't have a numerical data. For example, your marital status, your political party, your eye color, right? And even your gender, right? All this are under your categorical. Numerical means either it can be a discrete values or continuous value. What is discrete and what is continuous? Discrete means uh, if I ask you the age cannot be continuous. The age is discrete. You can say only one thing. For example, the number of children's, right? All these are your discrete. Continuous means your height, um, your weight, all this are your continuous variable. For a simple thing is, I will take the same example of your assessment, your unit test assessment. The discrete is, I just want to know whether you are pass or fail. You can say either pass or fail. The continuous is which mark you may get, right? Which mark you may get in this test. That is the continuous value, right? Okay. With this introduction, we will have some more detail, right? Now you know what is categorical, what is numerical, and what is discrete, and what is your continuous. Now, in the categorical value, what kind of measurements I can make? Nominal means you don't have any ranking. You know this marital status and gender is nominal. Do you have any ranking? No. If you have ranking, for example, even in your class, a student, a representative, right? In a teacher, you have a assistant professor, associated professor. If I have a ranking order, then that is a different case. Then that I call it as ordinal, right? If I don't have any or ranking, then that is nominal. If I have ranking, then that is your ordinal, right? And we have two more things, interval and ratio. From interval, there is a range. When there is a range, you call it as interval. If that range, right, if that range has a true 0 point, then that is your ratio. If I cannot have a 0 point, then that is your interval scalar, right? So these are all the four levels of measure. You call it as levels of measurement or different types of your way to assign your values to the variables, categorical variables. With this, okay, now I have introduced a two term, parametric and non-parametric. First, I explain you what is parametric and non-parametric, and then I come to this part. So what is parametric and what is non-parametric? Okay, we are taking census, right? For taking census, you have a range. You should know the population, right? If I want to know what kind of channel is being watched by this people in this area, then I have to define certain population count. If I make some assumptions on the population, then that is, if my further work depends on the assumption with population, then that is parametric. If I don't have such kind of assumption, then that is your non-parametric, right? That is your non-parametric. Normally, for parametric, you will use your interval ratio level of measurement, and for your non-parametric, you will use your nominal and ordinal. So what are all the operations I can do with this? Means I can classify, right? A nominal, gender, based on gender you can classify, right? And ordinal, we have seen you can include ranking. For interval, even you can perform your additions and subtraction operations based on the which we will see in later part of our sessions. Then ratio means you can apply your multiplication and division, right? With this introduction on basis of data, we will actually get into how data analytics will do. What I will do in data analytics means, given some set of data to me, right? I will design a model, right? For designing this model, I may use any of the predictive algorithms. So for this course, we will be discussing about linear regression and clustering for designing this model, right? Okay. So once the model is designed, right, when a new data comes, that model will tell me about the prediction. For example, you assume that I have a historical data about a bank account, right? About the set of transactions that happens in the bank. Based on that, I have designed one model. Now a new data comes, a new transaction comes. From this transaction, I can determine that whether it is the transaction may be related to getting a loan, a requesting for a loan. So I may make a prediction whether this person is liable to provide the loan or not, right? This kind of predictions I can make, or in other words, my historical data may be a set of temperature data. I design a model. That model tells if the temperature is so and so, I have to adjust my AC in this way, right? If a new data comes, it will automatically set the temperature. That is the prediction, right? And what we are going to see is you have different types of algorithms, and we will be seeing one supervised and one unsupervised algorithm. I will get into that, what is supervised and unsupervised in later sessions, right? With this, I put a stop on data analytic introduction. And then now I tell you why, how, we will speak about the characteristics of IoT data. And at the end, we will relate why I need to perform data analytics on IoT data. Shall I proceed further? Okay, fine. So, first let me see the life cycle of an IoT data. We know where it creates. It is created from the sensor. Then it is transmitted and it may be assembled in your cloud or in your edge device, right? Then from there, it may be for analytical purpose. I may process the data, right? Then I may store the data for later use, and once if the timeline exceeds, if I think no longer this data is needed, I may delete the data, right? This is the life cycle of your of any IoT data, right? Okay, during its life cycle, what are all the characteristics it achieves, right? We will discuss that. And before that, we have to speak about data size. What is this? We were familiar about bit. Bit means it has to be either 0 or 1, right? So I have given how the data scale increases. See, if I want, nowadays we are using Facebook, right? Your Facebook is actually, it has to handle a petabyte of data in a hour. What is petabyte of data? It is nothing but 1000 terabyte. What is 1000 terabyte? It is 1000 gigabyte. What is 1000 gigabyte? It is 1000 megabyte, right? So why this slide I have put in means you have to visualize how many volume of data, right? How much volume of data we are handling today, right? So as more devices or get connected, when you have autonomous vehicle, more devices or get connected, you need to handle a large volume of data. So when you have large volume of data, only you need data analytics to inform meaningful information from the large volume of data. Okay, so let us see the dimensions of your IoT data quality. So first we will see the characteristics, and then we will get into quality. Both are some or less interrelated. That is simple difference. Characteristic means it resembles like your big data. What normally you call a data as big data based on its volume, variety and velocity. What does volume means? As I speak, you have large volume of data. Variety means you will have different formats in your data. Velocity means the range of speed the data is being generated. For example, uh, okay, in patient monitoring, the data will be periodically sent, right? The data will be continuously sent to the monitoring station. In other case, I have a sensor in my fridge, right? It will send data only when there is a need. Only when an item is not present in my fridge, it will send the data. So there is a change in sending data, right? Generation of data. That is what velocity. Normally for big data, you say all this the characteristic, and this is also the characteristics of your IoT data. Then coming to your data quality, the data quality may be, that is what I said. See, the data quality. The data quality may be, the data generated may have inaccuracy in terms of noise, errors, and variable positions. And the timeline, right? The durability, how far I will use is your usability, and how quick I need the data. For example, you are moving in a vehicle, and the data about the person crossing is being sensed by your data, means that data you have to get it quickly. You should get it freshly, otherwise there is no use in getting the data. So these are all the things that determines your data quality. Completeness, it is not that always you get the complete data. Sometimes it may be incomplete, or sometimes you may have redundant data. Ambiguity is nothing but the same, you can consider it in two ways. The same temperature data can be used for two different purposes, and in other words, if I have multiple sensors, they may send a data with minor variations between them. You then inconsistency, the same, the what I have discussed is the same. That is, when you consider the context in which the data is being generated, you may have some inconsistency. Then you have your trustworthiness, how far I have to trust the data based on its source. All these things you consider when you handle your IoT data, right? Okay. Then, so this is the, when coming at high level, with high level abstraction, you consider it as two data. One is my big data and another is streaming data. So what is your streaming data? It is captured in short interval of time, and I have to make quick decisions like your remote patient monitoring and autonomous vehicle. Your big data is I have huge data set, right? I apply analytics to get business intelligence or transaction analysis. So we categorize into two parts. One is your streaming and big data for applying your analytics. Mm, when we discuss, we will take examples. We won't get streaming data. We will take a sample example, and the big data means you should have volume of data. We will not consider that much volume, but we assume a set of data or analytics that can be applied on big data for our further discussion. Okay, this picture gives the same thing, that the device is based on the velocity, how fast the reflection should be. If I need the response in milliseconds, then this sort of analytics has to be done in the device itself. If I need to get it in a minutes, I will do the analytics in the edge devices. If I it can take minutes, then I send the data to the cloud, and from there I do the analytics and get back the responses, right? Based on how speed I need to respond, the analytics may done either on the device, on the edge, or at the cloud. Okay, streaming data synchronous, as big data asynchronous. Okay, okay. One way this is correct, but I cannot say big data as always asynchronous. See, when I make a purchase, right, my data will be stored. I cannot say the data as an asynchronous, right? Okay. Okay. Apart from this four V's which we discussed for your IoT, you also have your variability and value. You also consider, you have also want to consider the value and the different types of data generated from different types of sensors when you apply your big data. Okay. So what are the challenges I have? The challenges is I have to process it quickly, dynamically, and I have variety of data. I have to consider the security of data. All these things are the challenges when I do work with my IoT data analytics. Okay. With all these introductions, now I get into what is your statistics. And today I am not going to touch your linear regression. Instead, I will discuss about correlation, which is a beginning step for your linear regression. Actually, it is an interesting part. For this, you don't need any computer science knowledge. What you need is your basic mathematics, right? With this understanding, we will start, right? So I have taken a simple example. See, I have given a list, that list of numbers 1 to 47. If I ask you to find mean, median, and mode, what you do? Mean is nothing but adding all the numbers and dividing by total number of elements, right? That is what your mean. In your when we speak in analytics, what you do, what you tell means these are all the sample values. What you tell is sum all the samples divided by total number of samples. That is what the difference of. The median is your middle number. Here I don't have middle number because I have four numbers up. So what I do, I take the two numbers in the middle, add them and divide it by 2. That is my median. So what is mode? Mode is nothing but how many times a number is repeated. Here I have no, a number is not repeated more than once. So I don't have any mode. right? What is the range of number? You have to find the largest value and smallest value, and their difference will give me the range, right? So all these things is not new for us. This we know from our 10th, right? So actually this is a basic statistics, right? This is the basic statistics. You find mean, median, mode, and range. The next level you go, you apply it for your analytics. Okay. Now, for this basic, apart from this mean, median, mode, and range, to have simple understanding on basic statistics, I will post you a material. You can have a glance on that. Now we will discuss about correlation. So what is correlation? It provides you a strength of linear relationship between two quantitative variables. Right now, this word is not new for you. What is quantitative variables? If I am able to measure it correctly, then I call it as quantitative. Yes, I can measure the height. I can also have measure my weight. Right, you have weighing scale, and I can use my scale to measure my height. So finding relationship between two quantitative variables. What is this linear relationship? Okay, before I get into that, I will ask you one question. Okay, let me have my temperature, room temperature, and the speed of my okay, and temperature of my AC, right? If the room, if the temperature is if my room temperature itself, you assume my room temperature itself 18 degree, right? Will you on the AC? No, first of all, you will not on the AC, right? If my temperature is say some 30 degree, you may put the AC and you may set it to some temperature, right? So I can have this as a data collection, or in other words, based on the temperature of the day, I may buy ice creams. If the temperature is so chill, right, I will not purchase ice creams. If the temperature is okay, I may purchase some ice creams. If the temperature is so hot, I will purchase more ice creams, right? So all these values I can put it as a graph. How it can be done? Hmm. In a paper, if I want to put a point, what are all the two things you need? You need x-axis and y-axis, right? So for understanding, I will take two variables for consideration. One is see, number of advertisements seen is 1 point, let it be x, and purchase intention may be another point axis, that is y. So this point, right, the point marked by my arrow represents number of advertisements and the purchase intention, let it be 1, 2, 3, 4, 5. So if I have seen one advertisement, my purchase intention is I will purchase two items. If I say two advertisement, I may purchase some, my purchase intention may be some 2.2. If I have seen three advertisement, my intention may be some 2.7, right? Able to follow this? This is nothing but I have pointed a values up. Now, correlation is nothing but how they are related to each other. See, increase in number of advertisements increases my purchase intention. So there is a relationship between them, and this relationship is positive relationship. That is, increase in advertisements in increases my purchase intention. In other words, otherwise, increase in explanatory variable will show an increase in response variable. This is the explanatory variable and this is the response variable. Why I call it as response means, see, based on the advertisement, my purchase intention increases. So it is the response because of this explanatory, right? So I call it as explanatory variable and response variable. Now look at here. If temperature decreases, right? If there is an when there is a decrease, See, when there is a decrease in temperature, the heater sales increases, right? Then I call it as negative correlation. When there is a decrease in temperature, the heater sales increases. That is a negative correlation. If one increases, the other variable also increases. If one variable decreases, then other variable value also decreases. Then you call it as positive correlation. If one increases, the other decrease, then you call it as negative correlation. If I can't find any such kind of relationship, then you say there is no correlation. Able to get the point? Why I do this correlation means I have to find a relationship between variables. For example, I tell you one thing. My mark, right? Whether I am pass or fail in a particular course, and whether I am a whether I am a hostler or day scholar, right? When I put it in such a case, sometimes there may not be high correlation, sometimes there may be a little correlation, but in other words you put my mark and my register number, will it be any relationship? There will not be. My mark and register number has no way relationship. It is highly non-correlated, right? So to find you find such kind of relationship between variables to pick suitable variables for your analytics. So this is the first step, correlation, and you have many different ways of correlation. One such correlation is your Pearson correlation coefficient. Only the name is big, but is simply easiest to one. See, this is the formula. You don't, it is an easiest one. Your x, and this x bar is nothing but the mean, and you know what is mean is nothing but adding the values and dividing by total number, right? So this is the mean. You are finding the deviation, x minus x bar into y minus y bar. You add it all them. Here x minus x bar the whole square, you sum it up, find the square root. Same y minus y bar the whole square, you sum it up and find your square root, and that is your Pearson correlation coefficient. If you have a positive value, then that is your highly correlated. If you have negative, then it is negatively correlated. If it is zero, it is no correlation. If the, see here, it is negatively correlated. -1 means it is negatively correlated. This is positive. Increase in one increases other, so it is positive correlation. It is a pictorial representation. I think it is so small here. Okay, I will take this example. Okay, I think now you could view it, right? Able to view it? Yes, okay. See, I have taken a set of x values. I will go with an example here. Okay. It is not clear. Okay, fine. Wait, just I will put it in. Okay, this is a Pearson correlation coefficient calculator. Even you can do it in Excel. For fastest way, I am doing here. I am putting a relationship. If it is one, to have a relationship, I will have multiplied by 2. So I will have 1, 2. Two, three, 4, 2, 5, 6, 7, 8, 9. And I just multiply by 2 just to have a correlation. it will show me a strongest correlation, that is 1. 4, 6, 8, 4, 8, 10, 12, 14, 18. Okay. I have X and Y values. You assume that this is the number of times I have seen the advertisement, and this is my purchase scale, purchase intention, right? Now I will calculate the Pearson coefficient. See, this is the plotted values. X is 1, Y is 2. X is 2, Y is 4. X is 3, Y is 8. I have plotted it as a graph. And you know how to find the mean. You have to add it up all values and divide it by the total number of items. Here it is, the calculation is done. Summation of X value, the mean value, and summation of your Y value and the mean value. From that you do x minus mx. Your mean is what? 5. So you x minus mx, the whole square, you find the mean values, you sum it. In the same way here you do it, you sum it, you multiply it, you apply here and you perform the calculation. The R value is 1. If the R value is 1, it shows it is highly correlated. If suppose I have R value as some point 0.05, then it is not properly correlated. If it is nearer to 1, in simple, if R value is nearer to 1, it is correlated. If R value is far away from 1, it is least correlated. If it is if it is of negative value, then it is negatively correlated. Okay, with this, I have given some sample examples, sample questions. I just read out the question. Suppose the correlation coefficient between an explanatory variable. It could be a size of a person home measured in square feet, and a response variable. The amount they need to spend per year in rupees, or it could be the amount they have to spend to purchase that particular home, right? The correlation between these two variables is 0.34, right? If this is the case, let me change the square feet into square meters. Square feet into square meters. Will the correlation value change? That is the question. That is, they have found a correlation between two variables, and they are asking if the values I was taken as square feet. If I change it into square meters, will the correlation value change? No, it will not change. It will remain the same because the correlation coefficient is unitless. I'm not finding any, I just unitless. You just find how they change with each other. So it will remain same. Then see the time how much a person, a student spent on food, right? The entertainment per week, right? These are the two variables, how much they spend on food and entertainment per week. The correlation between these two is identified to be 0.13, right? And they have taken a sample, that is, they have taken the readings of 270 students, which is most appropriate. 0.13 means that it is poorly correlated, right? It is poorly correlated. So you don't have a good linear relationship, but there may be non-linear relationship. You are not familiar with non-linear. I will explain you what is linear and non-linear in the next class. Now you know from this, with this minimum value, you know that they don't have strong linear relationship. Then again, by finding the correlation between this height and weight value, it is found to be 0.75, and they want to know the percentage of variability is not explained by height. For this, what you do is You do 1 minus r square. The value of r is given as 0.75. You square it, you subtract it with 1 and you find the value. This percentage of the plants cannot be calculated by height. These are all the simple examples of your correlation coefficient, and with this in the next class we will see linear regression. But for seeing linear regression you have to know about your straight line. Simple mathematics, how you draw your straight line. Y is equal to y equal to anybody can remember the straight line
Y is
equation?
equal to mx plus c.
mx plus c.
Y is
Super,
equal to mx plus
super.
c.
Yes. That's good. That's the split. I want the exact meaning of what is m, what is x, what is c, and what is y. Only that much
M
information
is
you learn
slope,
and
ma'am.
come. We will have what
M is
is
slope.
yeah,
m
yes,
is slope.
somebody m is slope. Yes, good. M
M.
slope and c is your y intercept. Right.
Yes,
Yes,
ma'am.
good. Yes, you just have a reading on this particular page and come, because what as you have given the answer, I tell you what we are going to see on next class. Actually, you're going to draw a line on your data set, right? That is what linear regression. Drawing a line in your given a collection of data, you try to find a suitable line that separates your data set. That is what your linear regression, right? That is what we will be seeing in the next class. Our intention is how to draw the line, right? In which way I have to draw a line so that it separates my data set in a right way. Ma'am, how can I implement it in signal processing? Okay, I am not the right person to answer this question, but I will refer and let you know how it can be implemented in signal processing. Actually, they use this in image processing. It could be used in image processing. I'm not sure how it could be used in signal processing.